Hey guys, it's Mrs. Barron. Today we are going to go over sections 8.2 and 8.3. I apologize, this first slide did not print correctly, so I had to rewrite it in marker. So today we're going to look at identifying similar triangles, and our essentials question is how can we identify these similar triangles? So I recommend for today's lesson, if you are able to, print off the guided notes so you can fill in different definitions accordingly. If not, totally fine, copy them on a separate piece of paper. But I really would like you today to, if you have them at home, get out a highlighter, markers, different color pens, whatever you may have, because those will be super helpful when we are determining how to identify similar triangles. All right, here we go. Okay, first thing I want us to think about, I believe it was Mr. Manner on Friday went over with you guys how to determine if two polygons are similar. So keep in mind that for two polygons to be similar, their corresponding angles have to be congruent and the measures of their corresponding sides have to be proportional. Okay, so keeping that in mind, today we are going to work on shortcuts for similarity that only works for triangles. Okay, so what we're going to look at is going to sound familiar because they are theorems that we use to prove congruency in Geometry A, but now we are going to use them to prove similarity in Geometry B. Okay. Alrighty, so our first theorem, and I'm going to zoom in here for you guys, okay, is our angle-angle similarity theorem. All right, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So what this means, if you have your markers, highlighters, pens with you of different colors, this is where we're going to start color coding to look at this. So this first triangle in CBA, okay, angle B is congruent to angle E. So angle B is congruent to angle E. Okay. And then I have angle A is congruent to angle D. Okay. So since these two angles are congruent, then triangle CBA is similar to triangle FED. Okay. Marked them up in colors so you could see how those two angles corresponded to each other. So that is our angle-angle theorem. All right, flip the page. Our next theorem is our side-side-side similarity theorem. So if the corresponding side lengths of two triangles are proportional, then the triangles are similar. Okay, so again, I'm going to color code and we're going to talk about how these proportions work. So I'm going to start with my longest sides. All right, so let me zoom back in here. I'm going to highlight my longest sides. Okay, and I'm going to work from longest side on the left to the right. So the bigger numbers first and working left to right. It does not matter which order you go in, you just have to be consistent. So I have 18 over 6, okay? 18 divided by 6, this is 3, so that's my longest side. Go to my next longest side, 12 and 4. 12 divided by 4, this is also 3. Okay, my shortest side I have 9 divided by 3, which is 3. Okay. Since all 3 of my proportions, the answer was 3, 3, 3, 3, I know now that these 2 triangles are similar because of side, side, side. So when you're going through problems like this and your answer, if all 3 times you do your proportion and in your calculator the whole number is the same or the decimal is the same all 3 times, then the 2 triangles are similar because of side, side, side. Okay? So this would be triangle BCA is similar to triangle STR because of side, side, side. Okay. Our next one, side, angle, side, SAS. All right, let's zoom in a little bit more here. Alrighty. If an angle of one triangle is congruent to an angle of a second triangle and the lengths of the side, including the angles, are proportional, then the triangles are similar. Okay, I first want to talk about the angle. So you'll notice that the angle on both of these, okay, is pinched between the 2 sides. For this SAS theorem to work, if you recall from last trimester 2, the angle has to be between the 2 sides that we're wondering if they're proportional. This angle cannot be only touching one of the sides. It has to be between the 2. It's between the 2 over here. Okay? So my angle X is congruent to angle M. Okay. Now let's look at our sides. Again, I'm going to start with my longest sides and I'm going to work left to right. Just have to be consistent in how we set up our proportions. Okay. So I have 6 over 3. That equals 2. Alrighty. We'll do our next side. I have now we have 4 divided by 2. And this is also 2. So my 2 sides right here are proportional. My angles are congruent and they are between my 2 proportional side lengths. So I have triangle, push this up just a little bit, ZXY is similar to triangle PMN, and that is because of SAS. Side, angle, side. Alrighty, so that is our 3 theorems that we are going to learn today, and now we are going to practice them. So if you have the guided notes, the next 2 pages go over the next problems we're going to practice together. If you do not have the guided notes, no problem. I would pause the video as we go through to draw these triangles out so you can practice these different theorems as I go through them. Oh, alrighty. Number 1. Okay. Put this as number 1. Alrighty, so let's look at what we have. First, let's look at our angles. C is 84 degrees and angle J is 84 degrees. So I have 2 angles that are congruent. Angle C is congruent to angle J. All right, now let's look at our sides. So I'm going to start with my longest sides. I'm going to highlight side AC and side HJ. Okay, I am going to set up my proportion now for my longest sides. 10 divided by 8. Okay, when I put this in my calculator, I get an answer of 1.25. All right. Looking at our next side, BC and IJ, keeping it consistent that I worked 10 over 8. I'm now going to put 5 over 4. Okay, I went in the same order. When I put 5 over 4 into my calculator, I again get 1.25. So my two sides are proportional. I have an angle that's congruent in between my two sides. It's between those two sides. So this tells me that I have my theorem to prove these two triangles similar would be side angle side and triangle ACB is similar to triangle HJI. Okay. Again, if you don't have the guided notes, take the time to pause it, color code as need be. Okay, let's look at number 2. Alrighty, number 2, looking at our angles. Let's start with our 90-degree angles. So I'm going to highlight angle G, and I'm going to highlight angle O. So angle G is congruent to angle O. And it looks like we have another angle that's congruent. So I'm going to highlight I, 67 degrees, and M is also 67 degrees. I is congruent to angle M. I have two angles that are congruent to each other, so we can prove these two triangles similar by angle. So I have triangle GIH is similar to triangle OMN, and they are similar because of angle. And this was number 2. Alrighty. Again, take the second to pause if you need to. Number 3. Alrighty, I'm going to mark up my angles first. Okay, so I have an angle that the angles are congruent, so I can say angle Z is congruent to angle T. Now let's look at our sides. Alrighty, so I'm going to start with my longest side. Okay, now if I set up my proportion for this, okay, and we go 3 over 10, just work left to right. Okay, when I put this in my calculator, I'm going to have 0.33 repeating, right? And we look at our other side. Okay, I have 2 over 5. Now when I put this into my calculator, watch what happens. I get 0.4. So this tells me these two triangles are not similar, and for more than one reason. Okay, our sides are not proportional. Okay. Okay, additionally, for this to have been a side angle side situation, our angle right here and right here, this angle would have had to be pinched between our two side lengths up top right here or down here. Okay, that angle was not pinched between those two sides. So even though it said they're congruent, this does not work because the sides are not proportional and the angle is not between those two sides. Alrighty, we are on number 4. Okay, so for number 4, it does not give us any congruency markers to start, but what we're going to have to do is think about some of the things we learned from Geometry A to mark up these triangles. So I like to call this figure the bow tie shape, and this bow tie shape right away cues me in right here at the middle that I have vertical angles that are going to be congruent. Okay, so these are vertical angles. Okay. The next thing I notice is my arrows. Whenever we have these arrows, okay, not to be confused with them being congruent, these arrows indicate that my 2 lines right here are parallel. And when we have parallel lines, they create alternate interior angles. Okay, so I have this angle, angle T, will be congruent to angle R. And that's because of alternate interior angles. When they're parallel, you get alternate interior angles. Okay, now we're ready to rock and roll. So I have angle R is congruent to angle T. And then I had angle RXS is congruent to angle TXU. So I have my 2 angles that we proved are congruent. So now we know these 2 triangles are similar because of angle, angle. Okay. Number 5. Alrighty, starting with our angles again. Oops. These are both 25 degrees. Okay. Angle I is congruent to angle J. Okay, but there is nothing else that these 2 triangles give me. There's no other theorems, nothing like vertical angles on here that we can assume. So for this one, there is not enough information to determine if they would be similar or not. Okay. Number 5, there is not enough information. Alrighty, number 6. This is our last one. All right, looking at our triangles right here, there are actually 2 different triangles we are looking at, okay? We have this triangle right here, and then we have the bigger triangle, okay, right here. What I want you guys to do for this problem is go ahead and redraw this smaller triangle off to the side. Okay, so I'm going to redraw it over here. I'm going to label my sides. This is B, D, and C. And my side lengths are 6 and 3. Okay, the next thing I want you guys to notice is that on this big triangle, this entire length right here is 8. Okay, we had to combine our 6 and 2. This entire side is 8. And then on the other opposite side, this is 4. We put our 3 and 1 together, and this is 4. Okay, all right. So, similar to the other ones, let's talk about angles first. If you notice, before we separated our 2 triangles, both triangles shared angle C. So that tells me then that angle C in my big triangle is congruent to angle C in my small triangle. They're the exact same angle, we just separated them into 2 different pictures. So I have angle C is congruent to angle C. And for good practice, we really should use 3 letters. So we'll call it angle BCD is congruent to angle ACE. Okay. Alrighty, so we have an angle. Now let's look at our sides. Let's start with our longest side. So that would be this right here on my big triangle. This is 8. And then I'm going to highlight it again here in orange. Okay, my two longest sides. I'm going to set up my proportion. 8/6. Let me plug this in. Get 1.3 repeating. And when we look at our smaller sides, let's use pink this time. I'm going to highlight my 4 over here and 3 over here. We set up our proportion. 4 divided by 3. When we put in our calculator, 1.3 repeating again. Okay, our two sides are proportional. Our angles are congruent and they are pinched between the two sides. So these two triangles are similar, okay, because of side, angle, side, okay. Triangle BCD is similar to triangle ACE. Alrighty. So now you have time to do some practice on your own. Okay, where on your Google Classrooms there is a riddle, okay, to complete. This is your independent activity for today, or independent practice, okay, your extra practice, whatever you want to call it. And then after that, your next step would be to complete the homework, which is today's exit ticket on your Google Classroom. Remember, completing these are part of your attendance, so be sure to get this done. If you guys have any questions, comments, concerns, please reach out to your teachers. We miss seeing you, hearing from you. Hope everyone is doing well, and we will talk to you soon. All right.